Now let's look at exploring tar, Gzip, Bzip version 2, as well as the zip program. These are all utilities that we can use to roll as well as compress data on your system. We'll open a shell and launch our notes and begin exploration. So we'll be discussing tar, Gzip, Bzip version 2, and zip. And they feature compression as well as file rolling capabilities. In particular, the tar utility allows you to roll multiple files into one image, although it doesn't provide compression. Compression is provided by utilities such as Gzip, Bzip2, zip, compress, and others. Now we'll begin by discussing Gzip. Gzip is a popular compression technique that is found with many of the packages that are available for open source applications online. So for example, if you download, let's say, MySQL or PHP or some other programs such as Snort, chances are likely the program will be made available in a compressed format and optionally in a rolled format using tar. Thus the suffix tar.gz is an example. So it provides a way for you to bundle or roll binary and text files into one file. So by file rolling or file rollers, we mean the ability to represent many files as one. And by many files, we also mean to include directories. So directories and files can be represented as one file and can be combined with compression utilities like Gzip, Bzip2, and zip to achieve considerable compression depending, of course, on the source file. So let's begin by discussing Gzip. Gzip is included on standard Linux systems, including Red Hat Enterprise Linux. It's available to all users on the system, and it's used to compress data. Let's navigate to the shell, Control-Shift-T to open a new session, and then execute a which Gzip. As you'll see momentarily, it's located in bin. The Gzip package also includes a utility known as Unzip. A which Unzip reveals that it's also available in the bin directory. So the two key utilities include Gzip and Unzip. Unzip decompresses Gzip files, and Gzip compresses / decompresses files. If you pass the appropriate option to Gzip, it'll compress or decompress the file that you want to perhaps transport or have occupy less storage. Now with that said, we need some text files to work with, and from a previous release of Linux CBT, we've got quite a few. For example, 1,000,000.txt. This is a roughly 6 megabyte file. Let's take a look at it. We'll lsltrh 1,000,000.txt, and it's about 6.6 megabytes. Now surely if we intend to transfer this document across the net, we can benefit from compression by using utilities such as Gzip rather than transmitting the entire 6.6 megabytes. Nowadays, of course, 6.6 megs is nothing. However, think of this in terms of 60 megabytes or 600 megabytes, and you'll realize the difference when it comes to moving the data across wide area networks. So how do we go about compressing that file? So our tasks include, 1, to compress 1,000,000.txt file using Gzip. And to do so, we'll simply execute a Gzip with the lowercase c option, which instructs Gzip to create a text file, or to create a Gzip file, that is, out of a text file that we're going to feed it. we first specify the source. That'll be 10 million dot text, or 1 million dot text, that is, followed by the destination, separated by output redirection. The default nature, we should note that Gzip auto dumps to standard out by default, which is why we need to make use of output redirection to send the Gzip compressed binary version of 1 million.txt into a new file, which we'll label 1million.txt.gz. So again, unless you use output redirection, or an option which will send the output, the binary output, to a file, Gzip will dump the output to screen. Let's go ahead and give this command a shot and watch it create that file for us, and then compare and contrast the differences in size. So we'll clear screen. We'll make sure that there is no other compressed version of 1 million.txt. There are PGP versions, but that won't impact our study. Then we'll go ahead and compress. This will be done momentarily, at which point we'll echo the exit status using echo question $, just to be sure that Gzip has successfully compressed the document. And it has. Now let's compare and contrast. We'll LSLTRH using the human readable format 1 million.txt star. So we see two files that are of interest to us. 1 million.txt, which is 6.6 megabytes, and 1 million.txt.gz, which is 2.1 megabytes. So it's a third of the original size. A file against 1 million.txt, the original file, reveals that it's ASCII text. The new file is a Gzip compressed document, so it's Gzip compressed data. So we've saved roughly 2/3 of the size of the original document by using Gzip compression. Again, Gzip with the C option compresses the information, but it does so to standard out by default, which is why we use output redirection to send the content to a new file, to a compressed file that we can use. Now there are other options such as verbosity. You can turn on verbosity. Let's remove RF 1 million.txt.gz and recompress using the verbose option so that you can see what takes place when that's turned on, using, of course, -V. And you can combine options instead of using multiple dashes. You may also alter the compression technique that's used, whether you want it to be faster or better compression. The default option is a balance or a trade-off between fast compression and better compression. So let's give this a try. Verbosity turned on, it tells you what's being compressed, and then it tells you how much compression was achieved. So roughly 2/3 of the document, the original document, the source document, has been compressed. In other words, we've realized roughly 2/3 compression, resulting in a 1/3 differential file. Super. So that's creating a Gzip file. Now, how about enumerating contents of an existing Gzip file? Using Gzip-L, let's create option D, followed by the name of the file, 1 million.txt.gz, will enumerate the contents of the Gzip file. At the command line, of course. It tells you the source file. So if we were to decompress the file, we would result or end up with 1 million.txt without the .gz suffix, and its total size would be 6.6 megabytes roughly. The compressed size, however, on disk is a third. So -L returns useful information, returns status information of the Gzip file. Now how about decompressing? Well, there are multiple ways to decompress the document. For example, using Gunzip followed by the name of the file will dump it to standard out. So Gunzip 1 million.txt.gz will dump the document to standard out. Let's give this a try. And it tells us that 1 million.txt already exists. It'll overwrite it. So this dumped it directly to the screen, to the file as opposed to the screen. So dumps to file the contents of the source file, 1,000,000.txt. So it's overwritten it for us, and it's re-represented it. Let's take a look at that. In its original 6.6 megabyte form, but it's updated the timestamp to reflect today's date and time. So Unzip will decompress the document for you. You may optionally execute Gzip. This is an alternate way to decompress data with a D option, followed by the name of the text file, the compressed file that is, with the contained text entry. Gzip-D will decompress. Again, Gzip-help, --help reveals the D option. So let's try this out. And it doesn't see it. By the way, we forgot to mention that when you Unzip the document, it dumps the file and removes compressed version, which is why we no longer see the compressed version of the file, which means we need to recreate it using Gzip create 1,000,000.txt, sending the output to 1,000,000.txt.gz. Once it's been created, and we could have turned on verbosity to see what fraction of the document had been compressed, but once it's been created, we could then use Gzip-D, and it overwrites the 1,000,000.txt file, the original source file. And when we echo the exit status, it's clean, exactly what we anticipated. Another way to preview the contents of a Gzip compressed file is to use zcat. Zcat 1,000,000.txt.gz dumps the content, or dumps the contents of the file to stdout, or standard out. So let's give this a try. It's a quick way to interrogate a Gzip compressed document as opposed to decompressing it. And because we've decompressed it, that is, it no longer exists. So let's recreate it, reset the buffer, and then re-execute zcat. And there you see it dumps 1 through 1,000,000 on the screen, as opposed to into a new file. Of course, when we use output redirection, we'll just break the process here. We can send the contents to a new file, such as test1,000,000.txt, and this will refrain from dumping the file to standard out. Now we have got a 6.6 megabyte test1,000,000.txt file, and it contains the contents of the original source file. So zcat is yet another utility that may be used to interrogate Gzip compressed file. Zcat, that's the name of the document. Another utility is less that we've just shown you. Let's list that as the F, or next option. Using the pager less followed by the name of the file will allow you to interact with the file. So it also dumps the contents of Gzip files to stdout. So yet another way, and it does so without creating a new file. So Gzip is a very important utility. Many of the documents you'll find online, programs, especially open source programs, and in particular source formats of those programs requiring compilation, are distributed using the tar.gz suffix, or using both technologies, tar to roll up the various directories and files, and Gzip to compress the contents of the tar archive, or the tape archive. Now let's move on to discuss Bzip. Bzip works similarly to Gzip, but Bzip version 2 provides a greater level of compression, especially for larger files. So with that said, let's create a similar section, labeling it Bzip2, and discuss some of the usages of this fabulous program. Supposing we wanted to create a Bzip version of 1,000,000.txt. Use Bzip2, and by the way, from the shell, you can always identify where it is. It's installed as part of the stock OS, so which Bzip2 will tell you exactly where it is on the system. It's in user bin. And if we use Bzip2, followed by a similar option to what was used with Gzip, that's a lowercase c option, followed by the source file, just like with Gzip, 1,000,000.txt, followed by output redirection, because as mentioned with Gzip, if you simply attempt to create a Bzip version 2 file using Bzip2-c followed by the source file, it tells you it won't write the compressed data to the terminal. because if it sends a compressed data to the terminal, which is represented in binary, it will cause all sorts of beeps and noises and potentially wreak havoc on your terminal environment. It will garble the text that you see here, so it doesn't do it. However, if you combine the output redirection that we've shown you as follows, then the file gets created as a Gzip version 2 file on the hard disk, which we'll have momentarily. Let's give this a shot. By the way, you can simply execute Bzip2 --help, and you'll see the options that are available, similar to Gzip, which includes a verbose option as well. So let's give this a try. We'll stick in the -v option for verbosity, and now it's compressing using the Gzip version 2 algorithm 1,000,000.text. It returns status information at the end, telling you the ratio. In this case, it's roughly 6:1 compression ratio, so if a file were 6 megabytes, it's now roughly 1 megabyte. And it has also compressed a greater version, or a greater amount, that is, a greater amount of the document than has the Gzip program. So with that said, let's take a look to compare and contrast between the two. Here is the Gzip version, or Gzip version, of the 1,000,000.text file, which achieved a great amount of compression to begin with, since it's a third of, or achieved 2/3 compression. But now notice we've achieved about 75% or more compression, roughly 80% compression, a little over 80% compression with the 1,000,000.text.bz2 file. This is a much smaller file, 1.2 to 2.1, for the sake of transferring across the net. Using email, FTP, SSH, any protocol you like, you still have to deal with the constraints of wide area networks, and this, as a consequence, the smaller you can make your files for transport, the better. The quicker things will move, the less clogging and congestion. So Gzip version 2 shines here. It doesn't always shine. It tends to shine with larger files, so we should note that. Gzip 2 tends to outperform Gzip on larger files. And by larger we mean 5+ megabytes, but not always. Just usually that is the case because the algorithm is tighter. Now, like Gzip, Gzip version 2 provides a counterpart, and it's called Unzip2. And just like Unzip, if you indicate the name of the file, 1,000,000.text.bz2, it will decompress the file. And just like with Gzip, you may also execute Bzip2 with the -d option to decompress the file. Let's reset this buffer and give this a shot. So again, this is a Unzip2, and it tells you the 1,000,000.text file already exists. If it does, then it overwrites it. Let's remove the existing copy and then try it again, and momentarily we'll have the original file. And there you see the 1,000,000.text file. And there it is. The original Gzip formatted file is there as well. Let's re-Bzip to it by using Bzip2. The most recent instance should work using the history, of course. By the way, this is another way to execute commands from your history by prefixing them with an exclamation mark. The last instance of Gzip version 2 will be executed to create or recreate the BZ2 file. So now we've got it again. As mentioned, we can also use Bzip2 with the -d option to decompress a file. In this case, 1,000,000.text.bz2 will decompress the file, overwriting the source file. Now, when you create a compressed file, in this case, it does not overwrite the source file. So if you attempt to decompress, it tells you the file already exists. And just like with the Gzip utility, if you execute Bzip2 --help, you'll see that there is a verbose option. You can turn on verbosity, and you can also take advantage of a blend between fast and best compression options. Now, just like with Bzip, or the Gzip, that is, the ability to zcat files, there is a bzcat utility. Let's go ahead and make note of that. If you want to examine the contents of a Gzip2 compressed document, use bzcat followed by the name of the document. In this case, 1million.txt.bz2. It will dump the standard out without decompressing the document. So dumps contents to stdout without decompressing it to disk. This will, of course, quickly dump all items, and you can pipe the output to a pager like less to see it one page full at a time if you'd like. But that's the essence of what bzcat will perform for you. Now you may be wondering, can you use less against 1million.txt.bz2? And there you see the answer, which leads us into our next method of exploring bz2 documents. Less is permitted. So less 1million.txt.bz2 also dumps the contents to stdout. Now you may be wondering, what about more? Since we did mention it's one of the pagers. Notice more dumps the binary to the screen. You may also be wondering, what about more with respect to gzip compressed documents, like this one, 1million.txt.gz? Let's give it a shot and you'll see momentarily. It's all gibberish. So there you see some of the subtle differences between more and less. We did mention that the less program supports the built-in ability to decompress various compression algorithms, including but not limited to Gzip version 2 as well as gzip. So that's a little bit about Gzip version 2. Let's move on. There's still other utilities to discuss before our 30 minutes for this segment are just about are up. So let's create this section as zip. And zip includes two utilities really, zip and unzip. So we'll label it as zip and unzip, just like bzip2 and bunzip2 and gzip as well as gunzip. So some simple usages for zip resemble the following. Zip followed by the name of the zip file. This is where it slightly differs. So zip followed by, let's say, filename.zip followed by the path is the usage. This is general usage. So in the case of the 1million.txt file, you'll want to create it as follows. Zip 1million.txt.zip space the path to the source file 1million.txt. Slight difference, because with bzip2 and gzip we specify the source file first, then the destination using output redirection. So we should just note zip differs slightly from gzip, and zip and unzip are older utilities, so that's part of the reason why it slightly differs, or they slightly differ from gzip and bzip2, in that the destination file or resultant zip file is specified before the source. So that means, conversely speaking, with the gzip and bzip version 2 programs, you indicate first the source, then the destination. But with zip, you specify first the destination, then the source. Let's go ahead and give this a try. We'll reset the buffer. By the way, if you've ever garbled your terminal console, you know that you can ungarble it by typing reset. Reset, close all the characters within a TTY. So with that said, let's zip 1million.txt.zip and then specify the source. So it's destination then source. Again, that's 1million.txt. This will create, and it's verbose by default, so it tells you what it adds, and it tells you how much compression it's achieved, roughly 2/3, as we saw in the case of gzip. Also, zip compression is comparable to gzip compression. So with that said, if we lsltrh, you'll see that the zip version is roughly the same size as the gzip version, 2.1 megabytes. So by far, the bzip version 2 file has achieved the most compression. To unzip the file, ditto. Just prefix zip with unzip followed by the source. In this case, 1million.txt.zip will do the trick. One of the neat things about zip and unzip is the ability to roll multiple files into your zip archive. So those files are treated truly as archives, where with Gzip and Bzip you tend to create compressed files one at a time. Zip treats a collection of files, one or more, as an archive, and allows you to stuff multiple files into the archive. But nonetheless, we can always tar then create a Gzip or Bzip version 2 file, which we'll be looking at shortly. So unzip 1,000,000.txt.zip prompts you as to whether or not you'd like to overwrite the source file, so we'll indicate yes, and this overwrites it. Echo status looks great. 1,000,000.txt has been created. It's 6.6 megabytes. So zip, unzip, very easy to use. If you want to know the type of document, just execute a file against it, and you'll get a sense for what it is. It tells you it's a zip archive. This is the same zip algorithm supported by WinZip and PKZip, PKUnzip for the Windows environment. So rest assured knowing that anything you create, any zip archive you create on your Linux system will be readable by WinZip, as well as the built-in zip algorithm for Windows, built into Windows XP, Windows Vista, so on and so forth. So you won't have a problem compressing or decompressing those items. Now let's move on. This brings us back to what we discussed earlier. The ability to create archives and then compress those archives, which is where tar and Gzip or tar and Bzip2 come together. This is where both worlds meet. So tar and Gzip / Bzip2, depending on your compression needs or preferences, or depending on what the person you are communicating with is able to support. Of course, if they're running a standard Linux box, such as a Red Hat, SUSE, Debian, Ubuntu, so on, they'll have no problems whatsoever interfacing with or interacting with Gzip or Bzip version 2 protected or compressed documents. But you still need to know, and to make life easier, use the format supported by the recipient. So how does tar play into things? Well, first and foremost, tar is used to create archives. And a simple way to create an archive is to execute tar with the C option, which is to create. We like to turn on verbosity V, and we like to force the creation of our archives, followed by the name of the archive, so such as filename.tar, followed by the path. This creates a non-compressed archive. So with that said, an example is as follows. tar cv f, we'll call it 1,000,000.tar or 1,000,000.txt.tar, so that we know that it contains a text file, although again the file program makes sure of that within a Linux setting. Followed by the source file 1,000,000.txt will create that archive for us without compressing it, which means the archive will be at least 6.6 megabytes. Let's give this a try. And then we'll lsltrh, where you'll find 1,000,000.txt.tar. Virtually no overhead is added to maintain the tar archive. So this is now a tar archive which is identical in size to, identical or very close to the source file. You can look at the byte differentials to get a sense, but an lsltrh or dropping the H would give you the actual byte count. For example, the source file is 6,888,894, and the new file is 6,891, which means it's bigger altogether. Slight overhead to maintain the archive, so we should just note that. Note, tar, like most programs, requires a small overhead for itself in each file. So just keep that in mind. Now with that said, how do we merge the worlds? How do we Gzip compress and tar? One other option is required, and that's all we have to do. Tar, instead of just simply CVF to create a tar archive, stick in Z, and if you stick in Z, then Gzip compression will be consulted, followed by the name of the file. So that's going to be 1,000,000.txt.tar, and we'll tack on the suffix GZ, followed by the source file, 1,000,000.txt. This creates tar gzip document, which means it will benefit from being rolled into one and compress. But you don't see the immediate benefit, of course, unless you create archives out of one or more subdirectories, including multiple files. So now we're creating this new document. Let's take a look at the result momentarily. We'll lsltrh, and there you see the new 1,000,000.text.tar.gz, which is 2.1 megabytes. How about tar bzip? Let's go ahead and give you that option. Tar cjvf, followed by what you see here, but just change a couple things. Instead of tar.gz, it'll be tar.bz2. That's a standard suffix. Same source file, but this now creates a tar bzip version 2 document, which means it will benefit from superior compression when the source file is larger. Let's create it, and then we'll lsltrh. And also that means that bzip version 2 is also a little slower than gzip as well as zip. So now we've got our 1.2 megabyte bz2 file. What does this all mean? Well, now these are both archives and they're compressed, which tar provides an interface into. If you use tar, for example, tvf, and in this case, since it's compressed, tzvf, and the name of the bzip version 2 file, you'll see the contents of the tar archive. So that's tar, and we've already got it in memory, 1,000,000.text.tar.gz, and this enumerates to the screen the contents of the tar archive. And if we use tar tj, so the same options we use for creation, but we're using t to display, for the bzip version 2, ditto. It dumps it to the screen. It gives us a sense for what's there. We could just as well use gunzip as well as bz2 unzip to decompress the contents of this tar image, but the items would be still rolled into the tar file. Now where tar really helps out is if you wanted to, let's say, add 1,000,000.text plus the test.rh5 directory and other directories and files to the archive, you can. That's where tar becomes very useful. So for example, tar, and we'll use bzip2 compression with the same source file, but we'll tack on some more. So in addition to 1,000,000.text, we'll also include, by separating with a space, test.rh5. This now creates a tar bzip2 document for the text file and test.rh5 directory tree, and it is recursive by default, meaning it will back up everything beneath the directory hierarchy, including files as well as other subdirectories. So let's clear screen and give this a try. You'll see momentarily that immediately after the 1,000,000.text file, it'll back up the contents of test.rh5, which includes any number of directories and or files. And now we've got a new file, and when we tar tjvf 1,000,000 text.tar.bz2, you'll see that it includes not only 1,000,000.text, but a full directory structure. And so long as you indicate n number of directories and or files after your tar instructions, you can add to your archive any number of directories and or files. They'll be rolled into one tar image and then be compressed either using bzip2 or gzip, and that's where you see the benefit of using tar in conjunction with gzip, bzip version 2, so on and so forth. So we've spent roughly the last 34 minutes or so discussing the wonders of gzip, bzip version 2, zip, as well as tar to be able to interact with text files, directories, and to roll them, compress them, decompress them, so on and so forth. Now when you find documents online, such as source files, you should have no trouble whatsoever extracting their contents and making use of them and getting right down to work. So with that said, we're going to continue our studies on other items that are key to your basic Linux knowledge.